Hey guys, welcome to the video. This is your study guide. I'm going to do the whole thing. So here we go. If x, y, and z are collinear, y lies between x and z, then this xy plus yz equals z or xz. Reason? True. That's a true statement. We don't need to have a reason if it's true. If two angles are complementary to the same angle, then those two angles are congruent. That is also true. It's one of our theorems. Don't need a reason. Consecutive interior angles always have a sum of 180. That is false. It's not always. It's only when we have parallel lines. 4. If two angles form a linear pair, then they are supplementary angles. That's true. It's the definition of linear pair. Number 5. If a line intersects another line to form 4 right angles, then the two lines will be parallel. That is false. That should say perpendicular. That's the definition of perpendicular lines, not parallel. Parallels would not meet. Okay, again, you're just making an explanation, so it can be really simple. This would have been sufficient for the test. Next. Sorry, I'm going to go fast through these just because we have a lot. 1 and 2 are supplementary, then 1 plus 2 equals that, so that should be def of supplementary angles. If ABC is a right angle, then ABC measure is equal to 90. That should be def of right angle. 1 and 2 are complements, 2 and 3 are complements, then 1 equals 3. This is technically the definition, or this is a theorem that states if two complementary angles are congruent to the same angle, then they are congruent. So that's what I put here, but that's a lot of writing, so I'm not going to write it all out. I'll say it one more time. If two angles are complementary to the same angle, then those two angles are congruent. Theorem. Boom. If PQ equals 32, then 2 times PQ equals 64. That is multiplying both sides, so that's the property, or sorry, the multiplication. Multiply property. Let's just simplify it, shorten it. Two angles added to make a larger angle. That's going to be angle addition. Postulate. ABC equals ABC. That's going to be reflexive. That's a V. Property. R is the midpoint of TS, and TR equals TS. That's the definition of a midpoint. AB equals CD, CD equals EF, then AB equals EF. That is going to be transitive. And last one here is segment addition. Posture. Next, positive, you need to watch it. Slower. Two lines are perpendicular, then they form 4 right. Def of perpendicular lines. Y equals 13 minus x, then 13 minus x equals y. That's symmetric. Property. AB minus 10 equals k. L minus 10, then I get this. What I had to do is I had to add 10 to both sides, right? So if I added 10 to both sides, these would cancel and I'd be getting with that. So what did I do? I did addition property. ABC equals 25, ABC plus CBD equals 84, then 25 equals measure CBD equals 84. That's going to be substitution property. If ABC and JKL are vertical angles and they're congruent, that's a definition of vertical. And JK equals LM, then JK minus NP equals LM minus NP. I'm basically just subtracting both sides by something, so that's subtraction property. Alright, moving on. Did this one in class, and I think every single class, but let's just do it again. Use the figure below to find the value of x and the measure of all the missing angles. These two angles right here are consecutive interior angles. So we're going to add them up and set them equal to 180, because my lines are parallel. And I have a calculator, so you can have a calculator on the test. Just make sure when you have your calculator out that you don't have anything there to cheat. So there you go. So I have a calculator. It's off screen, so you can't see it. So I'm adding up with my calculator. The easy stuff I'll do by hand, but you can kind of just double check with the calculator. You don't want to accidentally make a mistake. So I'm just going to go through this with doing basic math kind of more in my head. Divide by 8 here. We should get x equals 24. Okay, so we get 24 up here. Oh, that doesn't look good. Let's get that to look better. There we go. Okay, so that was my work. Set it equal to each other. And then what we want to do is we want to plug it back in. So we get 3x, which is 3 times 24 plus 20. My 24s keep looking like 29s. It's really annoying. Wow, Ryan, that is embarrassing. I mean, Mr. Smith. But 3 times 24 is 72 plus 20. We should get 92 degrees. So this angle right here, we're going to erase the CIA so we have a little bit more space. But this should equal 92, which means this one's also, you got to add up to 180, so this has to be 88. Okay. Notice 3 and these two angles are vertical, so this is going to be 88 degrees as well. And 2 and this are vertical, so that's going to be 92. Okay, and then we can see that this angle here and this angle here, which is 4, are corresponding, so they're going to be congruent, so that's 92. And then I can see that, let's see, the 5x minus 32 and 1 are corresponding, so they're going to be congruent, so that should be 88. Okay, so there it is. Boom, boom, boom. Next. All right, in this equation, we get y and 31. These are alternate interior angles, and these are parallel, so I know by the theorem that they're congruent, 31 degrees. And then for x, I see that this angle here and this angle here are consecutive interior angles, which means they add to 180. So I get 98 plus x plus 31 equals 180, which means x will eventually equal 51 using our calculator. Again, I showed you in class that one. You can actually do it a couple different ways. So, but I like consecutive interior angles. I'm drinking sparkling mineral water from Trader Joe's, orange flavor. It is so good. Oh my gosh. So I just wanted to give a little shout out. Trader Joe's sparkling orange mineral water. Oh, incredible. If I burp, I apologize, but it is really good, so I keep drinking it while I'm making this video. All right. Sorry, 23, name the special angle relationships. Special angle relationships, okay, the ones that I could have are CIA, alternate interior angles, AIA, alternate exterior angles, AEA, and corresponding. Those make up my special ones. We also have vertical and linear, but those aren't necessarily special relationships where it has to do with our parallel lines. So let's go ahead and write some down. We might potentially have the possibility of none. So 1 and 5 are corresponding. 8 and 2 are alternate interior angles. 9 and 7 are alternate interior angles. 12 and 8 are corresponding. 7 and 12, look at it, 7 and 12. They're 7's on the interior. So I wouldn't even look at this piece over here. Just looking here. They're on the transversal B. 7's on the interior while 12's on the exterior. Well, consecutive interior, those both have to be interior, those both have to be interior, those both have to be exterior. So the only option it could be is corresponding, but that's in the bottom right, that's in the bottom left, so no. The only possibility is none. 7 and 10. 7 and 10 are consecutive interior. 1 and 9, they're not even on the same transversal, so that's definitely a none. And 3 and 7 are corresponding. So we gotta look at 3 and 7 here. Can't look at this because it's not even on the same thing. but this is in the bottom right, 3 is bottom right, so that's corresponding. Okay. The rest of the questions are going to relate to this picture, so I have it off screen that I'm looking at. So make sure you're looking at your picture, so when I'm talking about it, you guys know what I'm talking about. Okay? So here we go. Alright, so this one asks us to go ahead and find the measures of all the angles. Okay? So I'm just going to kind of go through this one kind of quickly. I have the graph here with me, so I actually have the file open. It's off screen right now. I can show it to you. See, there it is. Boom. So I'm looking at it, but it's off screen. But basically it says 11 is 103, so obviously I'm going to put 103 here. So I'm going to go through them all verbally and put them in while we go. Angle 9 and 11 are vertical, so they're congruent. Okay. 9 and 10 are supplementary, so there we go, 77. 10 and 12 are vertical, so that's 77. If you look at 11 and 7, those are corresponding, so those are congruent. 7 and 5 are vertical, so those are congruent. 5 and 6 are linear pairs, so they add to 180. And 6 and 8 are vertical, so those are congruent. 8 is corresponding to 4, so 4 is congruent to 8. 4 is vertical to 2, so 2 is congruent to angle 4. And then angle 4 is supplementary to angle 3. And 3 is vertical to angle 1. And we get 103. So there you go. Those are all your angles. Again, it's only 2 options. Orange. Okay, so there it is. Next. Alright, so this one's going to take a little bit longer. On this picture, if we're looking at a picture 8 and 3, these are consecutive interior angles. 26, 8 and 12, or 8 and 11, I'm sorry, don't actually have a relationship, but I could show that technically it would work, that they are supplementary, so they are actually sup. And then 3 and 5 are alternate interior angles. Okay, so there's just my little setup. So here we go. We'll do the algebra. And so consecutive interior angles are going to be, they're going to add to 180. So we'll put 180. Supplementary obviously are 180, and these are going to be congruent. Okay, so we'll start it out 5x plus 4 plus 16x minus 118 equals 180. Okay, so we'll simplify this down to 21x. I have my calculator off screen, so I'm going to go ahead and make sure I'm using this. And so combine negative 118 and 4, and we should end up with negative 114 equals 180. Okay, I'm going to just do the math. Add 114 to 180. And we should get 294, and then divide by 21, and we should get x equals 14. Okay, now angle 5 is what I'm actually looking for, and if I look at my picture, 8 and 5 are supplementary, and 3 and 5 are alternate interior. So if I actually find the value of 3 is going to be the same as 5. So that's what we're going to do. So we got 16, and we're going to plug in 14, and then subtract 118. Okay, so 16 times 14 is going to be 224 minus 118. We should get 106. So that's the measure of angle 3, but they're alternate interior, so they're congruent. So we get 106 degrees for that. Okay, so 3 and 5 alternate interior angles, so they're going to be congruent. Okay, next one, we're going to add these two up, set them equal to 180. So we get 8x plus 9 plus 25x minus 60 equals 180 degrees. Go ahead and combine like terms, and we should get 33x. And then we're going to get, that's going to be 9 minus 60, so that's negative 51, equals 180. I'm going to add 51 to 180, and then divide by 33. and we should get a value of 7. Okay, I gotta find angle 10. When I'm looking at angle 10, I have angle 8 and I have angle 11. I can see that 8 and 10 are alternate interior, so if I plug it in for 8, I should get the same value for 10. So I get 8 times 7 plus 9. So 8 times 7 is going to give me 56, plus 9 is going to give me 65. So the measure of angle 8 equals 65. And 8 and 10 are congruent by alternate interior angles, so that's 65 degrees as well. Okay, last one. Let's give ourselves a little bit more room. These ones are congruent, so we're going to set them equal to each other. Okay, so we got to move the x over here and then add the 15 over there, so we're going to end up with 4x equals 100. So x is going to equal 25. Didn't need the calculator for that. Okay, now I'm looking at angle 12 and its relationship with 5 or 3. I'm going to pull this over just so I can look at it. But notice 5 and 12 are not corresponding, which means they're going to be supplementary. So if I can find 5, then I can find the supplementary to that, or the supplement to that, if you will. So let's go ahead and find 5. So that's going to be 25 plus 85. And if I combine those, or if I add those two together, we should get the measure of angle 5 should equal 25 plus 85, which is 110. So 12 is the supplement, so to get that to 180, we should have to just add 70. So this should be 70 degrees. Okay, there you go. That's the complete video. I hope you enjoyed it. I'm going to drink some more mineral water, orange flavor. Hope you have a great day. Test tomorrow. Make sure you have your notes, ICs, and performance tasks chapter 1 ready for me. Okay, here's a fun little picture for you. Perpendicular bisector!